figure. First things first, and this is a flashcard. Margin of error is 2 times the standard deviation. It's kind of like the 95% confidence interval as well, because we all know that 2 standard deviations on either side is 95%. So exercise 1, a recent poll found that 36% of all respondents would vote for candidate A. The poll reported, though, a margin of error of 4%. So if your poll and your sample showed 36%, and your margin of error was 4%, that means 4% above would put you at 40, and 4% below would put you at 32. That means that the actual percentage in favor of candidate A, we are 95% confident is going to be between 32 and 40. So we are 95% confident that actual support for person A will be between 32 and 40%. Our sample said, and this just happened, well, not just, I guess, it was a few years ago now, but the projected poll numbers that come out in a presidential election, that's just a projection. There's always a margin of error there, right? So give an interpretation of what this margin of error means in terms of support for candidate A. That's it. Okay? That's just a different phrasing. The 95% margin of error is the range of numbers between which a sample is likely to fall 95% of the time when taken from a population about which we know the mean and standard deviation. Don't worry about that. This is the phrasing that you're going to have to get used to. Okay? In any normal distribution, how much of the data falls within 2 standard deviations? 95%. So this margin of error is very tightly associated with the 2 standard deviations rule of 95%. Okay? Exercise 3 is a sample survey of 50 people, and they were asked about their favorite soda. 38% of them listed soda as their favorite, and the standard deviation of the sample proportion was 0.069. What was the margin of error? So you take your standard deviation and you double it. Okay? So times 2 would be 0.138. Okay? So 0.138. So if your proportion was 38, well, now one of these is in percentages and one of these is in proportions. So we're going to take, I don't know how you want to do it. We're going to take the 38% and we're going to give or take 13.8% from that. Are you with me? So plus or minus 13.8%, and that's going to give us our window. So the actual people who love soda A could be as high as 38 plus 13.8, 51.8%, or as low as 38 minus 13.8%, which is 24.2%. That's our margin of error is 13.8%. The acceptable range is that little window. Does this make sense? Okay? Make sure you're answering. They can ask it either one of these 2 ways. What is the margin of error? That's just double the standard deviation. End it there. If they ask for the acceptable range or an acceptable window of values, that's when you go low to high surrounding the actual average. Do you follow? Okay? Exercise 4, a poll of 500 voters. Candidate A led candidate B 46 to 39. So candidate A versus candidate B was 46% to 39%. And that leaves What's 46 plus 39? 85. That leaves 15% of people undecided here, right? If the standard deviations are both 0.022, so that's the standard deviation. Standard deviation equals, we'll just say 2.2%, right? Which means our margin of error is double that, 4.4%. That means candidate A, even though doesn't it look like candidate A is in the lead? Yes? I think we all can agree that just on that sheer number and that one result, it looks like candidate A is going to win. But if we throw the margin of error into this, candidate A really could be as low as 41.6 or as high as 50.4%. Whereas candidate B could be as low as 39 minus 4.4, 34.6, and anywhere as high as 43.4%. So even though A's window is still gonna be on the higher end, this is what happened in our last election. The reality was candidate A could perform this low, and candidate B could perform this high, in which case who wins? Right. So even though just based on those sheer numbers it looks like A is going to win, this margin of error leaves it possible that A could perform down here and B could perform up there, and candidate B could actually win. Okay? Margin of error comes up a lot, and it's thankfully kind of simple because we just double the standard deviation and you find that window. So on the back here we have a sample of 3 dozen jumbo eggs. How many is that? 36. And of our sample of 36 eggs, we weighed them all, we averaged their weights, and they had an average weight of 69.7 and a sample standard deviation of 0.53. Answer the following questions. I've since omitted A. So what would the margin of error be? So double your 0.53. So your margin of error is 0.53 times 2, 1.06. That's all they asked for B, 1.06. If they asked for the window, we would go 1.06 above and 1.06 below the 69.7. But they just asked for the margin of error. So jumbo eggs are considered to be eggs with weights at or above 70 grams. Is this within the margin of error? So our jumbo eggs technically had an average weight that was below what the definition says is jumbo, right? Yet they were still calling them jumbo eggs even though they weighed less than the 70-gram cutoff. Is this acceptable? So if I take 69.7 and actually come up with that window, on the low end 69.7 minus my margin of error would give me 68.64. And on the high end 69.7 plus 1.06 would give me 70.76. You would just show that window range and you would say, yes, it falls within the margin of error, or no, it doesn't. Does 70 fall within this margin of error? Yes. Is this within the margin of error? Yes. 70 is between 68.64 and 70.76. A lot of times there is a yes or no question, and your work showing that you've come up with the appropriate window range on either side of the average is partially part of your explanation. Okie doke? It's like when M&M's puts out a package of M&M's and on the front it says 12 ounces. Do you really think there's 12 ounces in every single package? No. I picture a factory and a little machine that allows a little window of a window range. Like if it says 12 ounces, it really has to have between 11.8 and 12.2. And I picture these packages falling off onto a scale, and if they're above 11.8 or below 12.2, they go in the good pile. If they're too light or too heavy, they get sold at TJ Maxx. That's what I picture. All right, so here comes your horn.